All right, this is lesson 5.3, so we are still in chapter 5, but it's a little bit of a switch. So if 5.1 and 5.2, we were kind of simplifying those trig functions, making it simpler and simpler with the identities. And if you found that kind of difficult, because there's different ways you can go with those, you'll find this a little bit of a relief, this next section, 5.3, because on these it's going to be very straightforward where you go with these. There's going to be a formula. It'll be pretty clear when you use this formula, and you're going to plug numbers into the formula and get out an answer in this section. So it'll be a little more straightforward than the previous two sections. Okay, so our section is called the sum and difference identities for cosine. So sum means plus, difference means minus. It's an identity for cosine. And so the question comes up, if I have the cosine of the sum of two angles, the cosine of A plus B, could I just break that up and have that the cosine of A plus the cosine of B? So something like this. If I have the cosine of 45 and the cosine of 45, would that just give me the cosine of 90? That's the question. Well, let's try and see. And do you remember your chart from chapter 1? The cosine of 45 degrees? Hopefully you still do. If not, you might want to pull it out and refresh your memory. But cosine of 45 was square root of 2 over 2. Cosine of 45 was square root of 2 over 2. The cosine of 90, guys, that's the x-coordinate. The cosine of 90 was 0. So is this true? Cosine of 45 plus the cosine of 45, does it equal the cosine of 90? And unfortunately, the answer is no. It doesn't work that way, which is why we need these other identities when we're adding or subtracting cosines. We need these identities for adding or subtracting cosines, called the cosine addition identity and the cosine difference identity. So here they are down here. So the identity goes like this. If I have the cosine of the sum of two angles, it turns out you take the cosine of the first times the cosine of the second, and then you get the second part to it. I'm not going to show you the derivation in the video. I can show you the derivation in class. You get the second part minus the sine of the two angles, and that would be the same thing as the sum of the two angles. So it's a little bit of a complicated formula, but not too bad. So it goes cosine of A plus B is cosine cosine minus sine sine. So notice there's a plus here, and there's the opposite sign here. Same thing for the subtraction one. Cosine of A minus B, it goes cosine cosine, and now it goes plus sine sine. And these are very useful if you have certain trig or certain angles you're trying to find before calculators. They're very, very useful because you couldn't just punch things in your calculator and get the cosine of values. And now you'll still use these occasionally if you take the next higher math course, which is calculus. These occasionally come up in calculus where you need to come back to these identities. So we've got these two. And like I said, I think you'll enjoy this more than 5.1 and 5.2 in terms of how straightforward this is going to be. So let's look at an example here. The question is find the cosine of 75. They would like it exact. So if you punch this in your calculator, you'll get a decimal answer, but that's not the exact answer. And instead you think, well, wait a minute, didn't I memorize some exact answers for cosine for 0, 30, 45, 60, and 90 when we're in degrees again here? So we'll label those degrees. Didn't you know these values? You did. Cosine of 0 was 1, cosine of 30 was square root of 3 over 2, square root of 2 over 2, and a half, and 0, but unfortunately 75 is not on your chart. So instead you look at your chart and you think, I've got these new identities for adding or subtracting. Is there anything here on my chart over here that I could add or subtract to get 75? And you look at it and say, oh, look at that. If I take 75 and break it up, 75 is 30 plus 45. So I use the values I know, which are right here. So you're still going to be limited in the questions they can ask. They can't ask you the cosine of 20, or they can't ask you the cosine of 55, because you can't really get 55 from some combination of these angles over here. But 75 they can ask. That's 30 plus 45. I look back at my identity. How does it go again? Cosine of A plus B is the cosine cosine minus the sine sine. So cosine of 30 plus 45 will equal the cosine, cosine, and it goes minus the sine and the sine. And then I've got to remember my table. I only made one column in the table with the cosine. You should remember the sine, and I'm writing it backwards from how we usually wrote it. We usually wrote the sine on the left and the cosine on the right. But the sine, remember, went up 0, 1/2, root 2 over 2, root 3 over 2, and 1. And I just read off all these values from the table. What's the cosine of 30? Square root of 3 over 2. What's the cosine of 45? Square root of 2 over 2. Minus, what's the sine of 30? 1 over 2. And the cosine of 45, square root of 2 over 2. Okay, are you good with fractions? You good with square roots? So combining this first one, square root of 3, square root of 2 gives me square root of 6 all over 4. The second one is the square root of 2 all over 4. So when you multiply square roots with different numbers, you can multiply any square root. So square root of 3 and square root of 2 gives you square root of 6. But when it comes time to subtract or add, they have to be like terms. So I can't put square root of 6 and square root of 2 together. I just leave it the square root of 6 minus the square root of 2. So we've just found the value of another trig function, the cosine, another angle, cosine of 75 degrees, that we didn't know before. Square root of 6 minus square root of 2 all over 4. That's it. That's our main idea. Let's try it again. Another example, how about 15? Well, look at your chart. Remember it had the 0, 30, 45, 60, and 90 on it? How would you ever get 15 degrees? You've got a couple possibilities, and either one will work. How about 60 minus 45? Or how about 45 minus 30? Pick one. Doesn't matter. Let's go with, it doesn't matter. Let's go 60 minus 45. Look back at the identity if you forgot it. The cosine of a minus b. Look at this one right here. It goes cosine, cosine, plus sine, sine. And it's just that simple, nice and straightforward. So it goes cosine, cosine, plus sine, sine. Look those values up in your table. Skip back to the page if you forgot. But the cosine of 60 is a half. 45 is a square root of 2 over 2. And this answer is looking suspiciously like the answer before. Sine of 60 is a square root of 3 over 2. Sine of 45 is square root of 2 over 2. Same rules apply. You can multiply anything. Square root of 2 over 4. Here's the square root of 6 over 4. I've got a common denominator, so I write square root of 2 plus square root of 6 all over 4. They differ by a negative sign. It's not quite the same answer as the previous one, but very, very similar. And again, they're still limited in what they can ask. They can't ask a lot of angles, but 15 they can ask because we can get that from 45 minus 30 or 60 minus 45. They ask 75. Or here they can mess with you a little bit. How about radians? How about pi 12ths? And how are negative? Well, several things. The first thing you should remember is we had an identity that said if you put a negative inside a cosine, it doesn't matter. So the cosine of negative pi 12ths is the same thing as the cosine of pi 12ths. And then I think for most people you'd be better off working in degrees than radians. So let's switch radians to degrees. Let's multiply by 180 over pi. Remember that conversion factor? And look at this. The pi's cancel out. And how many times does 12 go into 180? Look at that, 15 times. So this question really is the cosine of 15 degrees. And before you start doing that problem, hopefully you say, wait a minute, I just did that problem. So this is the same problem we just did, problem number 2. So at this point you stop and say, I've done that already. I remember the answer. It was square root of 2 plus square root of 6 all over 4. And just a little note to remind yourself, we can refer to problem number 2, the one we just did. It's not going to change the answer. So like I say, it's very limited questions, so certain questions are going to start looking familiar. It's like, I feel like I did that already. All right, can you do this identity backwards? So here's a cosine 25, cosine 65, sine 25, sine 65. You don't know those. Those aren't in your table. But let's look. That looks like the right side of our identity. We had here, it looks like this side right there. Cosine, cosine minus sine, sine. That's the right side. Cosine, cosine minus sine, sine. So replace it with the left side, which would have been the cosine of 25. Since this is a minus sign here, it's a plus sign here. So plus 25 plus 65 is 90. And I know the cosine of 90. It's 0. So sometimes I'll have it expanded like this. You say, wait, that's the right side of the identity. Cosine, cosine minus sine, sine. Replace it, nice and easily, hopefully, with the left side, and then do a little work on the left side, and you can look that up. So much, much easier than punching it into your calculator. All right, last question for the first video, last question that you need to know. True or false? Cosine of 41 plus the cosine of 13, would that equal the cosine of 54? And the answer is no. That's why we just spent time on these identities. Cosines don't add up nicely like this. You're going to find out later, neither do sines. Sorry, neither do tangents. So they do not add up nicely like this. So 41 plus 13 is not 54. That's false. Last one here. Oh, look, cosine, cosine minus sine, sine. That's the right side of the identity. Isn't that just the cosine of 64 plus 26? 64 and 26 is 90. What's the cosine of 90? 0. Oh, look at that. That checks out. So we will label that answer true. And there's a little bit more to do, but we're going to cover this over 2 days. So in terms of our first day, we have covered what we need to cover. We've got these 2 new identities, hopefully nice and straightforward. A little complicated, but not too bad. Kind of scrolled on now. You got these 2 identities, and we're practicing using those identities. And that completes this video.